Hello friends, this is the third question in line, which is again an execution through solver application. You see in this case again, there is a business situation where revenue is given for a couple of products, product A and B. Let's start working on this Excel sheet side by side. So you have two products, one is product A and second is product B. Okay, so and you see this grid is very important. If you understand how to create this grid, you collect the data clearly without any confusion. You see your output will be all good. So here revenue is given first, so I'm putting in revenue for A, it is 50 rupee, and for B it is 60 rupee. Apart from revenue, what we have in our second line is like requirement is given. Requirement is like what resources are you going to require. So what type of resources are there? You have raw material, so I'm writing raw material, and then second thing that you require is labor. Only two things are required, very easy. Okay, usually in questions you may get more than two requirements. So for producing 1 unit of A, you require 80 units of raw material and 90 units of labor. Okay, so for 1 unit of A, you need 80 units of raw material and 90 units of labor. Similarly, for making 1 unit of B, you require 150 units of raw material and 110 units of labor. You see, this is what is your situation on hand. Then you have maximum availability. Let's fix it up here. Availability of maximum availability of raw material and labor. In question, what is given is you have for raw material it is 20,000 units. For labor you have 40,000 units. This is your maximum availability, and then you see what quantity are you going to produce. Okay, so we are going to have an optimum mix of production. So I'm going to produce and maybe something from A and something from B. My ultimate objective is to maximize my, in this case, revenue is given. Okay, profit is not given, but revenue is given. So I'm going to maximize my revenue. So revenue maximization is to be done. Okay, so in this case, let's start with it. So first of all, we need to understand how many units to be produced. Units to be produced for A and then for B. So let's say we start with something called as 0. Okay, 0 0 I'm putting in. So this is my first starting point where we have to take an assumption that I'm going to produce 0 units of A and 0 units of B. Let's go and see what will be my consumption requirements. And when I'm saying there is something called as constraint means a limitation. Okay, so I have a limitation here for my raw material. I cannot consume beyond a particular limit. So if I need to compute my total consumption for raw material, which is this cell, you see what I'm supposed to do is like I have to see how many units I'm making it for product A multiplied by consumption of raw material for product A, plus similarly I'm going to make some units of B also. And what is the requirement of per unit of B when it comes to raw material? It is 150 units. So when I press enter, because units are 0 and 0, hence my total consumption is going to be 0 only. Similarly, I'm going to do total computation of total units consumed of labor while manufacturing both A and B. So 0 units of A, let us assume 0 is what you are producing, multiplied by units requirement for product A when it comes to labor, which is 90, plus units of production for B multiplied by requirement for product B in terms of labor. Okay, this is again going to be 0. Okay, now this is your consumption. Let me make it yellow again. So these are again formulas, these are number. What we need to maximization is to be done. So how do you calculate revenue? Revenue is nothing but this 50 rupee multiplied by how many units are you manufacturing, plus similarly 60 rupee revenue for every product B multiplied by total number of units that you are manufacturing. So when you press it, this 0 is a master 0. Let me color it red and 0. Let me make a bold 0 here. So this is your objective function. So in solver, first you have to start with your objective function. So objective function is to maximize your revenue. Okay, so this cell has a formula which is actually used for computing your revenue. And this is your objective function. These are your two constraints. And then let's go into data tab. I'm clicking on data. Under data, you have solver. In solver, you see, you need to start with something called as a master formula. So this is your main objective. So here, this 0 is your main objective, which is nothing but the total revenue generated by both product A and B. Situation is of maximization. I'm not, you see, I feel like no one will say it is a case of minimization, because for a business, maximizing your revenue is your key. So you have to pick up maximization. In case it might have been a case of costing, then you should have gone for minimization. But right now, it is a maximization case. By changing variables cells, which cells are variable in this case? You see, these are the two cells where units of A and B are mentioned, which is 0 0 presently. So these are the two cells which can change a bit. Okay, now with this, let's go and add constraints. Constraints are your challenges. So let's add constraint to it. So you have to see total amount of consumption that you are going to do for raw material. This cell, which is G9, should be less than equal to which value? See, 20,000. Okay, I'm putting in this cell reference of F9. This is first constraint. Second constraint is this cell, which is G10, which actually represents total consumption of labor while doing this production. Is like this G10 is nothing but it has to be less than equal to which value? This value is 40,000, because 40,000 is your maximum value. You cannot consume more than 40,000. Then again, I'm adding it. These two values, which are the units of production that we are going to do, cannot be less than 0. It has to be greater than or equal to something called as 0. So why I'm telling you this is like production cannot go into negative. Once you are done with it, add. And then one more constraint. You see, one more constraint is like when I'm going to produce something, production has to be complete. Partial production is not allowed. Let's say you're making TV, fridge, washing machine. Can we make a partial TV? No. Hence, again, another dimension which is important is like when you're going to manufacture any unit, you have to take a whole number. Okay, so I'm picking up both C11 and D11. These values should have an integer, a whole number. Okay, it should not be in fraction. And then when you say okay, you see, you can see four constraints. First one is where it is like both values have to be a whole number. Second one is where both values have to be greater than 0. Any production cannot be going to negative. Then the next two constraints are related to the consumption of material that you have. Okay, maximization is done. Now we'll apply solve. We are going to keep solve a solution. When I say okay, can you see here? 250 units of A is recommended and nothing from B is recommended. Even though 50 rupees your revenue for every unit of A, which is 10 rupee less than what you have in B, but still, you see, system is recommending you to make only A and not to make anything in B. Why? Because you see 10 rupee margin is there, but you see all resource requirement is almost double in case of raw material, and you have a limitation on raw material. So you need to keep these things into mind and just see something. Like you see in this case, availability is 20,000, consumption is only 20,000. Availability is 40,000, consumption is 22,500. So we are still left with 17,500 units of labor, which is unused. So we can transfer it to some other department. So if you know this, it helps you to achieve the target of optimization, resource optimization. And I'm trying to maximize my revenue, which is 12,500 in this given case. And you see, you calculate any method, you use any calculator, output cannot be better than this. Okay, so I hope this is clear to you. Good day, take care.